All right, so we're moving along here in 8.4, day two. Same exact idea. I'm just going to show you a few more different types of problems. So we're sticking with multiplying, dividing, and simplifying, and we're just going to have a few more problems that are maybe a little bit more involved. But again, it's great practice for factoring. In a normal year, this would lead us right into our final. And it's really, really, really good review for the final because it's a lot of factoring. So, again, those of you headed to pre-calc, this is going to be something that's going to be used quite a bit. And we talked about two different examples here. We turn division into multiplication. So I don't do anything with the first fraction, and I flip the second fraction. Okay. So, so um, after I do that, now I look to factor. So I've got x cubed over x squared, and I'm going to factor the top is the difference of two perfect squares, which is x plus 1, x minus 1. All over on the bottom, I'm trying to find two numbers that multiply to negative 8 and add to negative 7, and that would be x minus 8 and x plus 1. And then I look for my common factor. So I've got an x plus 1 and an x plus 1. This x cubed and x squared is the exponent property, so I just subtract, which would leave me with an x on top times x minus 1 all over x minus 8. Okay, so notice the x squared canceled down here. This canceled to just an x. And again, when I do this, we don't really want to multiply this back through. We just leave our answer like this in simplified form. So I know it says multiplication or division, and we just normally don't ever divide or multiply. Okay, so here there's no division, so I just start factoring right from the get-go. So I've got 9. I take out, it gives me an x plus 8 all over an x plus 8, x plus 2. That's two numbers that multiply to 16 and add to 10. Over here on the top, it would be x minus 9, x plus 2, all over x minus 9. So then you look to see if you can cancel. The x plus 8's cancel. X minus 9's cancel. X plus 2's cancel. This whole thing is the same thing. No matter what I plug in for x, I will get the number 9. Okay. Again, factoring. So lots of different factors here. So we're going to take out, starting with the top. So we're going to take out an x. It's going to leave me with x squared minus 4 all over a 4x squared x plus 10 squared times. Here I'm going to take out a 2. It's going to leave me with x squared plus 4x minus 60 all over x squared minus 8x plus 12. So I'm going to look at each individual top and bottom, numerator and denominator, see what I can factor here. So at the top of the first fraction, I can take the difference of two perfect squares, x plus 2, x minus 2. On the bottom here, I'm just going to rewrite this out as x plus 10 squared means x plus 10 times x plus 10. You don't have to do that as long as you know that x plus 10 squared means that there's two of them. On the top, on the second fraction, I'm going to find two numbers that multiply to negative 60 and add to positive 4. So it would be x plus 10, x minus 6. And on the bottom, two numbers that multiply to 12 and add to negative 8 would be x minus 6, x minus 2. So now I look to see what I can cancel. This x right here cancels with this x squared, and I'm left with just an x. This x plus 2 does not cancel. This x minus 2 is gone. This 2 cancels with this 4, and the 4 becomes a 2. So I'm left with a 2x down here on the bottom. X plus 10 cancels. X minus 6 cancels. So again, the whole point of doing this is to try to simplify the fraction as much as possible. And I'd be left with an x plus 2 on top. That's the only thing that's left up here. Okay, over. On the bottom, I have a 2x, and I have an x plus 10. The key is when you cancel to keep things organized. I try to do that here to show that I'm left with a 2 and an x to show the 2x. So that's all I'm left with in the denominator, and that would be simplified form. Okay, another one, again, no flipping because it's all multiplication. So I'm going to take out a 6. That's going to leave me with x squared minus 100 all over a 3 times x minus 10 times difference of two perfect squares, x plus 10 x minus 10. And then on the bottom here, I've got an x squared. And I'm just going to write out again x plus 10, x minus 10. So I look through both top and bottom. Is there anything that still needs factored? And up here, you see that this is still the difference of two perfect squares. So what did I do? That should be a plus 10. Okay, so take the 6 out, x plus 10, x minus 10 over 3 times x minus 10 times x plus 10, x minus 10, all over x squared, x plus 10, x plus 10. And we start canceling. The x plus 10s cancel. The x minus 10s cancel. The x plus 10 cancels. The 6 and 3 cancels to a 2. So on the top, I'm left with 2 times x minus 10. On the bottom, I'm left with x squared. Again, just because this is an x minus 10, you have to have a pair for a pair. So I can't cancel this x minus 10 with this one as well because I chose to cancel it with this one. You have to cancel one at a time. They have to come in pairs. So look at another example here where now we have 3 different things that we're looking at with a division sign. And we have to remember what we do with division is we flip it. So the first fraction I don't do anything with. I'm going to go ahead and factor. That gives me an x plus 2, x minus 3, two numbers that multiply to negative 6 and add to negative 1, times x minus 9, x minus 3, all over, take an x out, leaves me with x plus 1. Remember, we're dividing here. And then here, I'm going to flip it. X plus 2 over x minus 9. So now there's nothing left to factor since I already factored everything. So I'm going to cancel what I can. I'm going to cancel the x minus 9s. I'm going to cancel the x minus 3s. I'm going to cancel the x plus 2s. And I'm left with a 3 on top and an x times x plus 1 on the bottom. So they just look a little bit longer, but it's the same process. Lots and lots and lots of factoring, which is very good review. Okay, this problem here, I want you to look at it. There's 2 ways that we could go about this problem. I'm going to show you what I think is the easiest way. This first step, we're not used to seeing it this way. This is the difference of 2 perfect squares. So if this was a 25 minus x squared, whenever you have the negative in front of the x squared, I always like to recommend taking a negative 1 out. Look what happens if I take a negative 1 out of the 4 minus x squared. It becomes a negative 4 plus x squared. And if you rewrite this, you have a negative 1 x squared minus 4, just using the commutative property and flipping these things around, right? This is something we're very used to seeing. This is a little bit different. So I recommend anytime you have the difference of 2 perfect squares where the variable doesn't come first and the variable's negative, to do the commutative property and flip them and then take a negative 1 out. Look, if I distributed this negative 1, it'd be negative 1 times x squared, which is negative x squared, and negative 1 times negative 4, which is positive 4. So I just recommend doing that. It makes it easier for us to factor. So now here I've got and I'm just going to rewrite it now, over x plus 2. And then I'm going to change division to multiplication. So I'm going to put the x plus 5 on top and the x squared plus 10x plus 25. Now I can factor everything. So I've got a negative 1 times x plus 2, x minus 2, all over an x minus 2, times x plus 5, x minus 5, all over an x plus 2. And then x plus 5 on top here, all over an x plus 5 times x plus 5. So let's start canceling. I've got the x plus 2 cancels, the x minus 2 cancels, x plus 5 cancels, x plus 5 cancels. So this whole thing cancels down to a negative x minus 5 with nothing left on the bottom here. Okay, now I said there's 2 ways to do that. You also could have just factored the top here to 2 minus x and 2 plus x, all over x minus 2, x plus 5, x minus 5, all over x plus 2, times x plus 5 gets flipped over x plus 5 x plus 5. So now here's where it just gets a little bit tricky. The x plus 2s, you should clearly see that this cancels with this. Doesn't matter the way that you write this, positive x plus 2. So those things cancel. The x plus 5s cancel. X plus 5s cancel. Here's where it gets a little bit tricky. If you see that these signs are exactly opposite, right here is where I'm talking. This 2 is positive, this 2 is negative. This x is positive, this x is negative. Those are exactly both opposites, okay? It's not like an x plus 5 and an x minus 5 because the x's are both positive. So it's not like that. They literally, both of these are opposites. This will reduce to -1 every time. So it leaves me with -1 x minus 5. Really, it's what you ever use.